So anyways, my name is Brian Schwab. If you've never heard of me before, I was in the video game industry for a really long time. I probably shipped like 20 something titles. My last actual professional game that I shipped was I was the AI and gameplay programmer on Hearthstone at Blizzard back in the day. It's going on 10 years at this point. After I left Blizzard, I joined a tiny startup in Florida called Magic Leap. Zach knows what I'm talking about. I ran the rapid prototyping group there called the RealXP Lab. We did a bunch of first turn on of all the systems of the crazy hardware that we were building. I did a bunch of experiential exploration with those guys and worked with all of the incoming content partners to sort of figure out how to use this device. And so the interesting thing is that, like, yes, I've worked in gameplay and AI and crazy interaction work for most of my life, but I also have done a kind of weird swath of different types of debugging, right? Which is part of the reason why I've done this talk in the past, is because like my view of debugging is a little bit more holistic and slightly more structured maybe than others, right? Since I left Magic Leap, I've actually worked at Lego. Lego is a very interesting place in that they're not, you know, what a lot of people think of as a tech company. However, the thing that I am currently working on within Lego is somewhat tech-based, and so that's why I'm there. If you're wondering what the heck I'm doing, right? So yeah, that's me in a nutshell. In the South of America, we have a phrase called "there's many ways to skin a cat," right? There is many ways to find, reproduce, and get rid of bugs. I would go so far as to say that you will probably spend more time as a developer debugging than you ever will actual coding, and yet I have yet to ever see a class on advanced debugging skills in school, right? It's one of those things where there's a lot of stuff to know and stuff to think about, and maybe things you can plan ahead of time and all of that, and yet you basically learn all of it on the job, and even then, only if people are into it as much as they should be, right? It might just be something you kind of like deal with for most of your experience. So today I'm going to talk about a number of things. I'm going to talk about some general notions, right? I'm going to talk about some architectural stuff that I've done in the past. I'm going to talk about a little bit of weird tricks that when things get extreme, when you can't rely on certain things that you maybe need. And then I'm just going to go over some weirdly random stuff that I've seen or done in the past that ended up being good in a debugging universe. So as far as general notions, in my mind, a lot of debugging is just basically about getting more signal and less noise, right? You're trying to figure out what exactly is going on, and you really need to separate out what is a cause from what's a correlation and all of that, right? And so I always say you need to know your context. Again, I'm going to go over a little bit of a list, and then I'm going to go a little bit deeper into them, right? You need to know your context, right? In any given investigation, you need to know what your ground truth is. You need to know how you got to that spot. You need to know not just the particulars of the situation, but like the path, right? And then there's so much data flying around at any given time that you really have to figure out how to focus your attention so that you can separate, again, what things are important at any given moment for whichever bug you're really dealing with. You need as much information as possible, again, so that you can maximize your ability to get that signal. But nobody can actually like work if there's just so much stuff coming at them at once, right? And so figuring out, you know, how to cull down some things so that you can make sense of the chaos is just as important as getting actual signal, right? So when I talk about context, I tend to say when people come up with bugs or you read a bug report, right? There better be some particular pieces of information on there, and if there isn't, then that's the first thing to go dig for, right? So how frequently does this happen is the biggest one, right? Is it happen every single time? Is it completely random? If you don't have a frequency on your bug report, you need to train your tester. That's the very first thing that they should do, is say, oh, I've repeated this 3 out of 10 times or 10 out of 10 times. It means that it always happens or it barely happens, or, you know, so just 3 question marks, and I've had it happen 4 times in the last week, right? that is a crucial piece of information, not just so that you can like not go insane trying to find the dang bug, but also so that you can like prioritize which ones are the most important to fix first. The next is the reproduction steps on the actual thing. Which of these things don't actually need to happen? Always watch for sometimes, because again, that means they haven't figured out the actual frequency. Or they say, then I think you type statements. That means they maybe haven't taken the time to reproduce, or excuse me, lower the amount of steps in their reproduction to the only min viable things. Like if you have 10 steps in a bug report, and if one of them or two of them says, I think you have to do this, then they should have, as a tester, remove those steps and see if the bugs still happen or not, right? Like you got to work your testers as much as possible to try and get them to sort of do some of this work for you, because it's just more and more stuff. How long has this been going on? Did it just now break? Who checked something in recently? Does it have anything to do? Like history can be just as important as anything, because like it tells you like what recently changed outside of the executing program, right? And that kind of thing. And finally, like if it was a group of people that did this, you should probably talk to everybody, because it might be somebody goes and mentions something that isn't in the bug report, or it's something that they noticed that the bug tester didn't, that kind of thing. So context is really, really important to sort of start with. If you hear this sort of statement, that's impossible. How is this working at all? How did this ever work? Is a phrase that I've heard, I don't want to know how many times while making stuff. I usually tell people, okay, it's time to stop and play a little game that I call, we go to the whiteboard and we play a little game called the big list of knowns, right? And everything that you think you know, we're going to write on this board, right? The whole 9 yards, we're going to write them all down. The reason why I'm doing this is because the word impossible, or this doesn't seem like it could happen, that basically means that something that you think is true is blinding you from seeing what's really happening, right? You've got a blind spot somewhere, and now we need to find your blind spots out, right? So you list all the things you know, and guess what the next step is? You do every single one of them and make sure that all of those things are true, one by one. This is sort of like the software equivalent of somebody's mom saying, my computer doesn't work, and the first thing out of everybody's mouth as they groan is they say, is it plugged in? Did you turn it off and on? It's not because you think your mom is an idiot or anything like that. It's because people don't tend to think of those things. So let's just check everything, right? Let's just check everything and make sure and run through the list. And I find that running through the list actually helps people, because like if they write down everything they know and they checked everything and it still doesn't happen, right? Still doesn't figure things out, then maybe you need to talk about the process. Maybe there's something involved in how meticulously you just checked everything that is now causing the bug to not reproduce, when if you run at normal speed, everything it does work, right? There's something going on. One of the things in your list that should have been there isn't, and it's about the process, right? And lastly, keep a list of all the times that you use this sort of method and it works, because that might point you to automated stuff that you should probably write, because it turns out that some of the process is got too many human steps in it and it's just prone to error. So we should probably automate that, because 4 of our last 5 wins have always been in this one step or in this one part of checking everything, right? Or likewise, if another win points to something, it might actually change your list of things, right? So that next time that doesn't happen quite so often. So it all goes back to, again, if I have dogmatic beliefs, like those represent blind spots. So don't know something, right? Make sure, actually check and make sure that you do know, and that you're not just sort of like believing something that you think is right. So now you know the context of everything, right? And you actually know your blind spots. But if you just see the current state of what's going on, then yes, that's important, right? If you're a crime investigator, you need to come in and go, oh, look, there's the body and there's the 2 bullet holes. And there's a spot over on the mantle where there's no dust, because that's whatever got stolen was sitting before. And you can kind of get a snapshot of things, but you really need to start thinking like, Dr. Strange and saying, what timeline happened that got us here, right? And like, what are all the possible futures that like we could have had instead? Because in many cases, that's the only way you're going to really figure out what's going on. In fact, that's what crime investigators do. They try to reconstruct the timeline. They try to think about possible scenarios, and they try to get there, right? So you need to know why. But you need to know the whole train of logic that got you here, right? Like each system, and especially if you're talking about a complicated AI system or maybe a really complicated physics system or an animation thing that's doing crazy IK as it goes across different, you're working at Ubisoft and you're trying to climb trees at speed or something. The whole dependency train of like how you got here is in some ways more important than just what's currently broke at this second, right? And likewise, if you have a lot of possible options, the thing where it broke might not actually be where the bug is at all, but one of the branches of your code that didn't fire, right? Like knowing what didn't fire and why it didn't fire might actually be the actual place where the bug is. So I'm not so caring about the tree that my car hit. It's more about the fact that the person driving is drunk. That's the real problem, right? It's not that end result that is the bug. Once you do know the whole path, it probably gives you a heck of a lot more information as to like how to replicate this bug, right? And you might even be able to sort of like store some of this logic so it's easier to jump in here and retest once you do know how to potentially fix it, and you can try it out and get going much, much faster, right? But if you do have some randomness in your game, one of the other things that's really useful is to actually like potentially visualize some of that randomness while you're looking at things, because you might have stuff that like you can spot by gauging some of that randomness, some of that variability before it ever even becomes a bug. You might be looking around a level and see that one of your spawn points is like hanging out in midair, or maybe even that the variation radius around that spawn point hangs out over the edge somewhere. And so 8% of the time, one of your creatures is just going to spawn and just fall immediately to their death, right? And that might be a bug. It might not be a bug. It might just look stupid. But by visualizing some of your possibility in your system, you can actually spot the bug when it did happen because of that range, but also like maybe spot bugs before they happen. And let's talk a little bit about visualization, right? Like you've probably seen screens like this. You've probably built screens like this over your life. And if you have, you know that like for some odd reason, most people that are making advanced debug visualizers love the color green and blue. I've not exactly figured out why, given that 16% of men in general are red-green colorblind, but whatever, it is what it is. This is actually a fairly decent visualization of probably a nav mesh scenario, right? A lot more what I see are pretty janky sort of visualizations where there's text everywhere and it's 5 different sizes and you can only read half of it, and some of it is in world, so that means you can't read it unless you're standing in this exact spot, and you know the bounding box on this guy is going through the floor. Like all sorts of weirdness is going on in this particular shot. I think it's kind of funny, but it does look a heck of a lot more like what you see. But I mean, I've also seen like hideously complicated, visualizations that's not text, but it's like data, right? Like this is a level where they're showing all of the different connectivity between connections, and it might be like jump points and where the jump point goes to. And yes, you might need all of this data in order to really debug this if you're a level designer on this thing. But like, I can't even imagine if all of that was visible at the same time as all that text was visible, I wouldn't be able to do jack squat with it, right? And so this is where I'll talk in a sec about really sort of getting a sense of like, what do I need to debug at this exact moment, right? And like really just sort of going, I just need line of sight information right now. Let's just look at that for right now. In fact, I want to change the camera angle so I can actually see what the heck's going on. That kind of thing. And then next, I'm going to turn this layer off and I'm going to put on the layer of the nav mesh. And then I'm going to turn that layer off. And then I'm going to put on the layer of where I can jump from back and forth. But if you have complicated visualization, you really need to be able to kind of like hone in on things, because suddenly you're awash in way too much craziness, right? So I've worked on some games in the past where the AI system or the gameplay system and the animation was so complicated and so crazy that I really needed to go deep on like actually making the game itself kind of help me to be able to debug things, and to give me enough data to actually even figure out what the heck is going on. Now, I got lucky in that in the middle of my career, I worked at Sony for a while in their sports studio. And even though I wasn't a sports guy, I worked on their basketball game for 9 years, something like that. And one of the things that sports games have that's beautiful is like a replay button. You push the pause, and I can just rewind backwards and forwards and watch what happened, just like a regular sports television broadcast, and get a sense of that. And what I did was I actually piggybacked on the replay buffer, as it was called in the sports game world, and I basically made a rewind system for the whole game at that point, right? Like I piggybacked on that so that I could make um, debug data be something that we were storing in the rewind buffer, so that like you could then access all of that data uh, as you went backwards and forwards, right? Um, Now the good thing about this is that very quickly, you know, you if you have this, you can kind of store quite a bit of stuff. You can take frame by frame steps backwards and forwards. You can do all sorts of good stuff, right? You the other big thing that I'm going to talk about after the buffer is making sure that you make it easy to deal with your non-code stuff as well, right? So let me get to that. Um, a lot of people are like when I bring this up, they're like, well, but Jesus God, how much memory are we really talking about here? Like, you know, if I have a complicated game, that could be an insane amount of memory that I need. I will say I've made replay buffers that are 10 seconds, 15 seconds, 30 seconds is pretty good. Um, I've had replay buffers that can be huge if you really figure out a good way to like compress them and don't write them all the time and that kind of thing. It's actually been um, a fascinating sort of thing to figure out like how much memory you really need, and what sort of things you're going to store. You can kind of do the whole thing of like, well, I'm just going to store the inputs and I'm just going to regenerate the frames. It gets a little weird if you're not kind of like very deterministic and potentially even like animation based or purely physics based, right? Because like then suddenly sometimes physics simulations don't do well with negative delta t's, and sometimes animation systems don't do well with weird interpolations and da 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 da. So the point is that like I tend to sort of like say only save the things that you really need. But if you don't have to, if you have a completely deterministic game and it's completely physics based and you have the ability to go backwards and forwards, maybe you just store everything, especially if you have the memory, right? It ends up being kind of case by case basis based on like what you have available to you and what the hardware is letting you do at any given moment. But because we're talking about a lot of data, uh, um, you really do need to like allow yourself to like sort of sit. I want to look at the animation system while I'm stepping backwards and forwards. I want to look at the network events that are going on right now. I want to see what the AI is doing. I want to see this, and kind of jump back and forth. Eventually, on that particular sports game that I was doing, it became such a popular feature, this rewind buffer, that like I think there was like 114 debug pages based on various people making their own pages and being able to debug whatever they were working on at any given point. And I think I went a good 3-4 years where I never had to debug anything at my desk if I didn't want to. I would be walking around in the studio and anybody that was playing the product would be playing along, and they all just got really, really used to me sort of going, pause it. And whoever it is would just jam the pause button, and I'd walk over and I'd take the joystick away from them and I'd go into the replay and I would back it up and I would turn on some debug and I would sit and go back and forth and I'd be like, aha, the frame 37 of this animation that this playing has a way too big of of a bounding box on this particular limb. And so then I would go bug the animator about what was going on there. And I would just hand the joystick back to the person, and I've just debugged a bug from 30 feet away. I just saw something that didn't look right out of my eye, and I said, pause it, and I was able to find that bug. It would have taken me, I don't want to know how long to figure that out. Waiting for a bug tester to catch that, write it up after they reproduced it, and then have somebody go and do that. That would have taken forever, right? And from the Magic Leap years, I found out that like XR, spatial computing or augmented or virtual reality has a ton of additional need for something like a rewind buffer. You have way more high fidelity streams of input. You have a lot of weird nuanced calculations that are based on multimodal things that are being fused. And also there's a lot of weird environmental stuff. We actually had a full rewind system on the interaction lab at Magic Leap. We called it what did we call it? It was like IT Walker or something like that. I don't remember the name. Somebody named it weirdly. We found this one bug where something was going on this far side of this one room for whatever weird reason, and we couldn't figure it out. And I remember I was like, I watched somebody do it. The bug happened. I went into the walker. I backed up their head pose, and I was like watching their head pose go through space. And I realized that like this one particular place where the bug was happening, there was actually a window open up there, and there was a big shaft of light that was going on. And because I could see that shaft of light was going across where their head was going to be, I knew that like there was a chunk of light that was actually hitting one of the sensors on the Magic Leap device, and that's what was actually causing the bug at the time. It was the most ridiculous thing because there happened to be an algo that was favoring high contrast world anchors, and that shaft of light was super high contrast, suddenly like wave of light coming at it, and it was sucking all of the world anchors out of that direction instead. Craziness, right? Never would have found it if I didn't have something that I could rewind time and step back and notice that there was a chunk of environmental light that there wasn't in somewhere else, because obviously that's not anything that we were logging at that time. And so likewise,
I'm just curious. Sorry, I just have a quick question. Was it just taking like video feed that you could rewind, or was it actually like, storing like all of the variables of the game back at a certain amount of time or something?
In that particular case, we were storing head pose and eye gaze and hands and some video as well, but as well as sort of some fusion variables that we were doing on the side to do various things like sentiment and some other things, right? And so we had all sorts of things that were going on. Like, so I had like 33 lines that would like travel through space backwards that I could sort of see where, I moved in this direction, but my eyes were looking over there, and I was scratching my head. You know what I mean? We had all of that information backwards in a trail, and we had like a little avatar that you could see when you rewound back, because we weren't obviously like still seeing the person that was doing the thing. But yeah, we had all of that information sort of stored in the walker so that we could like rewind back.
Cool.
From a in being able to decipher what's going on in the code, you really have to make sure that the stuff that's not code isn't the problem, right? Go back to that like list of stuff I know about, right? If I can record data, I can use those recordings, right? Like now, if I have done a buffer, I can use that recorded data to like test assumptions, right? I can record a certain chunk of data, and then I can change something in the code and play that exact same chunk of test data. And now if it's red instead of green, I know something changed, either good for the good or the bad, right? I can use that as sort of like almost like a human in the loop unit test at that point. The bug testers, when they do stuff, can actually give us chunks of recorded data instead of just a video feed of the bug happening. They can give us a recorded replay buffer of the bug happening, and then we can even jump into the code at that point and load a replay buffer and like start from there. And likewise, like you can actually use recorded rewind data as actual animations in your game. There was a game a million years ago called Skate, where they built these like hideously complex environments so that you could skate around in them, skateboard, right? But then they realized that like getting the NPCs to like sort of use the environment intelligently was like insanely difficult. Like it's not just pathfinding at that point, it's sort of like skate pathfinding, which is not a thing, right? And so what they did instead was they just basically recorded all of the testers playing the game, right? And then they used all of the test data for various characters traversing the level, whether they succeeded or not, as effectively animations for, oh, if you come from this angle, there's a bunch of recorded data that lets you jump up onto here and do a trick or three and fall down and do blah blah blah. And it was all just basically recorded testers that they used for all of the AI data for Skate, right? It was all just recorded replay buffer, basically. But the other thing that besides just your code is also like, what's the configuration? You know, am I in the European branch or the Canadian branch? Is this an Android title and it's built for like 19 different types of hardware, and I accidentally have got the wrong version that I'm looking at here? Am I in the main branch or the pre-production branch or some sort of special thing off to the side? Like knowing that information, making sure that's written into the bug report will save you a crap ton of time, right? It's just stupid to not know that. And likewise with your asset database, I really need to know version control and what's going on with various assets, because in many cases, either the scripting languages is an asset or even the audio files themselves and that kind of thing. I might need to roll back an asset change because it may have broke something. Let's find out, right? All of this. So I put this here because like you really need to build your architecture around knowing that you want to do some of this stuff, and it will definitely help, but it's upfront costs, right? So sometimes, you know, you have debugging situations that are not just, you know, you didn't do everything you could, but you're extremely limited in certain ways, right? Like what if you don't have a debugger at all, right? You can't really stop the code or step through or check a variable, any of that. You can still use log files. I mean, everybody tends to go, well, you can still use log files, right? You can throw various things in your code that just sort of like print out to a big nasty ass text file or some sort of, you know, Twitch stream gone awry that just flizzes by on the side of the screen, and you do your best to sort of see stuff. I have watched people debug AAA products with the most horrible log system and no actual debugger, and it makes me sad every time I do it. I'm just like, what are you doing, right? This is crazy. But sometimes you don't have the time, you don't have the code, you don't even have the people that can do it well. Okay, I see. You're doing with what you can. You know, log statements can get it done. It becomes a science on using log files, and you end up having to filter your own logs in order to get it all done, and you become a little bit of a data scientist on your log files. But you know, whatever. But what if you don't have any logs, right? What if you not only have no debugger, but you can't, like, you have no bandwidth to send a log, right? Or you can't even send events because, again, you're bandwidth bound. Like your game actually uses all the bandwidth possible in order to run. So if you start adding additional debug stuff, suddenly things go bad in a hurry. A lot of times what I've done in the past with this is, like, maybe I do stuff where I spawn something in game, or I tweak stuff in game that happens when things are going on, so that, like, I can't really see it in a debugger, and I don't have any log statements, but you know, maybe a signpost happens every time something happens, and it points me in the direction of a bug for all intents and purposes, right? There's other things you can do, but it gets tricky in a hurry, right? And one step further, what if I can't really take up any resources, right? I have no extra memory or CPU, or it's a timing bug, and so if I futz with the timing of the the game at all, it actually really messes with stuff. At that point, you actually have to figure out a way to put additional debug signal into the running game itself. I've done a couple of games where like we had a couple of frames of art that we would use when certain things would happen. It would just switch from this color guy to that color guy, which allowed us to sort of see things happening, but it didn't take up any extra memory or any CPU. Sometimes you end up having to allocate just a tiny bit of memory so that you have some debug resources loaded in at all times so that you don't have to like suddenly try to introduce that once there's a bug, right? And timing bugs can be tricky. I have literally worked on a project before where it crashed like a madman until we put 3 no-op statements in the right place so that things took a little bit longer, at which point suddenly it started seeing that variable after it had gotten loaded, and therefore we didn't have that bug anymore, right? Timing bugs can be pretty insidious to fix, and it's a tough situation, and I wish there was a bit more that I could say general purpose for that, but that becomes kind of tough because it's like, is it a timing bug because it's a cache miss, or is it a timing bug because it's a a refresh problem, or what really? If you have no testers, I really pity you because finding bugs is definitely a full-time job. But so is regressing bugs, right? Like you make a bunch of fixes, having a group of testers that can go off and like retry all of the bugs to make sure that they're not there anymore is an insane amount of why the game industry went from everybody was always crunching to we didn't have as much crunch after a while. And it's partially because we realized that if we didn't have a dedicated testing department, we were asking every single programmer in the company and most of the artists to do 2 or 3 jobs, right? Because then suddenly everybody became a tester as well as their normal job. It was horrifying, and it's not good because nobody really actually enjoys regressing bugs. That's not a thing unless you're some sort of sadist, in which case then you're a professional tester. And lastly, you might not even have access to the end product directly, right? Or the right environment in which it's going to be, or maybe even like this is built for very specific customers. Like maybe you're making, an experience for kids, and you don't actually have a lot of access for little kids to be doing testing on your product ahead of time, right? And it turns out that some of the bugs maybe are because kids move in a different way than the adults do, and it's difficult for the adults to replicate that exactly on a regular basis so that you can find bugs that you find once the kids start using it. Again, one of the ways I've done this is like if you do have any way to record data, you can record data maybe in the very limited times in which you are in the right environment or with the right sort of stuff. You record that data and then you can use that when you don't have access to sort of like now try to test it more frequently. You can also try to do it in a simulation sort of a thing. You can use Monte Carlo testing to try and like find bigger and bigger variations that get you closer to where you maybe are bulletproofing things so that when you are in the right environment, you don't end up in a bunch of craziness that you never tried, that kind of thing. It's a tough situation, but it can be gotten around. This last chunk I want to talk about is just, like I said, sort of random stuff that I came into over the years that like is interesting to think about because it's just sort of like, okay. I worked at one place where one of the sort of like head genius programmers, he had perfect pitch. And this is a long time ago, so I'm going to say, because it's not as common anymore, but it was a PC game that we were working on, and this particular guy, he had perfect pitch, and what he would do is he would actually access the PC speaker at various times in the course of his game loop, and then he would just run the game, and it sounded like a modem, an old school modem going off. So it would be like, and he'd be like, see that? That's a lot of A sharp, right? Like I expected at least 2 A sharp tones for every B flat, and I'm only hearing one A sharp tone for every B flat, that means that my networking code is actually out of lockstep with my, and you're just listening to him and you're like, my God, that's amazing. Like, he found a way to increase the amount of signal that he was getting using a superpower of his. But I've worked with other people that, like, they had bugs on the database, would send them an email because it was on another server and there was no way to get the information to them any other way. I've had signals happen where people would hook up Bluetooth devices, and then we didn't have any bandwidth over the internet connection or whatever, but we could spin up a little Bluetooth stack off to the side and send things to a Bluetooth. It's amazing how quickly you start looking for additional ways to get information out of a system when your back's against the wall, right? And so think about, what could I potentially do that, like, maybe makes no sense at all, but it ends up being the only way that I can find things if I really, really need to. Runtime analysis is pretty cool. I talked about, like, just having a stream of log files going in the side, but, like, you can also do stuff like, I'm just going to tweak the color of the cursor or the crosshair in the middle of the screen based on some variable, right? So, like, if I'm doing it right, it's mostly green, but every once in a while, if I see a red flash, I know, and like, with a little bit of information, you can run that runtime analysis, and you can actually really find a lot of bugs just by sitting and trying stuff over and over again and having really, really good timely feedback that, like, helps you find the causation and correlation really quickly, just simply because there's almost no latency, right? And so that runtime analysis can be really good. In fact, it tends to lead to, like, putting that runtime analysis into the game loop itself for some reason, for some occasions, right? Like, if you find that, like, you're having trouble getting users to use a particular control, like, you put a little bit of that same thing where, like, if I'm standing in the right place, I get a nice clear signal between red and green, and now suddenly you've got a gameplay debugger for people that are playing the game on something that's a little bit difficult learning curve. And the same thing, because the latency between feedback and their effect on the system, they can learn that way faster and actually figure it out. It's actually pretty interesting, like, how many times I've seen that happen. You can put a ton of smarts into your editor if you have any form of scripting language or node-based system. You can do syntax checking and logic checking and loop checking and oh, somebody left these 3 parameters out. You can do anything from throwing events while the game is running to not letting them save a level file if there's something missing, or you can ask them, like, hey, this is out of whack. I once had a designer on a game I was working on. It was a huge data-driven system. It was all this crazy tree-based logic system that we had built at the time, and we shipped the game. And a week after we all got back from taking some time off after the game shipped, I was looking around in a file, in the main game file, and it turns out that this poor designer had literally commented out 3-ish months of his own work, and then we shipped it, right? Because we didn't commented out data blocks in the same way that, like, the code editor, if I commented out, if I block comment something in code, it turns bright whatever, and everybody knows it's commented out. And we didn't do that in the editor, and this guy commented out a huge chunk of the tree, and we shipped it, And I said, well, I'm sorry to say we shipped it that way. It was a yearly sort of game. It was at that sports studio, and I said, well, guess what? You got 3 months of free goodness for next year. And so he killed his entire contribution to that year's game. It was kind of sad, but we learned very quickly, make sure that if you're going to comment something out, allow somebody to comment out, make sure they can see it real easy. And lastly, one of the things that I've found over the years that works insanely good for not only finding bugs, but also for determining how better to put additional signal in for future things is to just sit and watch the playtesters play. Because A, you're going to find, is there a particular bias in the way that they're playing? Like maybe most of your testers sit back in their chair and they've got their hands up and they're doing this. And yet most people that are sitting in their couch are playing it down here. And it turns out that the difference in having the weight back this way actually slightly changes the angle of your thumbs. And I actually found a bug in a game one year that was literally because all of our testers played a certain way, right? And it was just sensitive enough that it was catching it up. It was one of those things where I was early enough in my career that I learned a big lesson there, which is like, don't make the controls unforgiving enough, right? Because then suddenly they're not accessible to a larger group of people. But it took me a heck of a long time to debug that, because nobody over in the dev studio was playing the game like that, because we weren't spending 8 hours at a stretch playing the game, where we were sitting back in a chair with our TVs halfway up the wall, right? Which is what the testers were doing. And so it was interesting to just sort of like spend large chunks of time sitting behind the testers watching, so that I could get a sense as to like, what do they do differently than us? What are they doing over and over again that I never would have suspected? And so I should put that into the code as either checks or whatever. All kinds of stuff that like, these are professional breakers, right? And so sitting and watching them gives you a good sense of like where maybe bugs might be happening, or where you can put additional stuff to like make sure that you can either find bugs or you can prevent them, right? So questions.